Good morning, dear students. In the last class, we have learned about the nomenclature of fatty acid. Today, in this section, we will learn something about triacylglycerols or TAC. These triacylglycerols are also known as neutral fats. Then, what are these triacylglycerols? They are simply esters of trihydric alcohol, that is glycerol with fatty acid. So, glycerol with fatty acid is triacylglycerol. And what would be the number of fatty acid for becoming that fatty acid to a triacylglycerol? For becoming triacylglycerol, they should present 3 fatty acids. Then only it can be a triacylglycerol. If there is only 2 fatty acids, then that fatty acid we can call it as diacylglycerol. If there is only one fatty acid, then we can call it as a monoacylglycerol. Okay. So anyway, this is the structure of triacylglycerol. We can see that trihydric alcohol glycerol as its backbone, and to this 3 fatty acid chains are attached. As there is 3 fatty acids, that's why it is called a triacylglycerol. Then which are the different types? Mainly through 2 types are there, simple triglycerides and mixed triglycerides. Simple means in that type of triacylglycerol, all the fatty acid attached to the glycerol are of same type. So that is simple triglycerides. Example, tripalmitin, then triolin, etc. So that tri itself indicates that all the fatty acids. There is no other mentioning of a different fatty acid here. So that is simple triglycerides. Then mixed triglycerides means what? In such type of triglycerides, at least one fatty acid be different one, not the same one with when compared with the other 2 fatty acids. Generally speaking, the pattern is that pattern of the mixed triglyceride is that only one fatty acid, attached to the third hydroxyl group will be the different one. Examples are 1,3-dipalmitoyl-2-olein and 1-palmitoyl-2,3 disterin. So from the name itself, we can understand the pattern of fatty acids. In this example, first carbon and third carbon it is attached with the dipalmitoyl, and second carbon is attached to olein. And in this one, first one is connected with which type of fatty acid? Palmitoyl. And second and third, that hydroxyl groups are attached with a diasterein. And one more condition exists, that is whenever a PUFA means polyunsaturated fatty acid is present among these fatty acids connected to the glycerol, it will occupy which position? Second hydroxyl group or the beta. This is the alpha, beta, and gamma. So, if whenever a PUFA type of fatty acid present among these 3, that will occupy the second position, second hydroxyl group. Let's see what are the physical properties of triacylglycerols. These triacylglycerols are hydrophobic, and hydrophobic, why it is hydrophobic? Because of the presence of long chain non-polar hydrocarbon chain triacylglycerol. We know that triacylglycerol contain glycerol plus 3 fatty acids. Okay, so because of the presence of non-polar hydrocarbon chain, these triacylglycerols are hydrophobic. And hydrophobic means water hating. So that's why it is insoluble in water. That is first point. And second one, this triacylglycerol can exist as oil. Is a condition. What is the nature of that type of triacylglycerols? For existing in the form of oil, the temperature should be 20 degrees Celsius, and also that type of triacylglycerol should possess high proportion of unsaturated fatty acids, or otherwise it should be of short chain triglycerides. That means the fatty acid contained in such type of triacylglycerol should be of short chain. That type of triacylglycerols are called oils. And these oils are generally of plant origin. Okay. Two conditions: 20 degrees Celsius, high proportion of unsaturated fatty acid. Also, at the same time, the length of the fatty acid should be short. Next, it can exist in the form of fats. It is a condition. The temperature should be room temperature, and the fatty acid that should be mainly of saturated one. Saturated one means there is no double bonds, and we have seen that as saturation is more, it permits more compact packing, and it can increase the hardness, solidness. So that is why they are more solid when compared to oils. And these fats are mainly animal in origin. And these points are again explaining here. When the constituent fatty acid in triacylglycerols, if they are having higher chain length, the chain length is more, and also that fatty acids mainly of saturated one, then that can increase the hardness. Why? It can have a more tight packing. So such type of fats are called hard fat. Example, pig fat. And those fats which are having medium chain triacylglycerols or unsaturated fatty acid that will give a more loose packing. So that's why they are known as soft fats, or their texture, their consistency is soft, and its examples are butter and coconut oil. In the coconut oil contain medium chain triacylglycerols. Examples, which are the triacylglycerols we can find inside in the coconut oil: lauric and myristic acid. Okay. Next, we are going to see the reactions of triacylglycerols. Before moving to that section, we need to understand one more point. If we take the case of a person having normal weight, 15 percentage of his weight accounts for triacylglycerol as his storage fat, and that too is stored in adipose tissue. Adipose tissue, we know it is simply the body fat. It's a connective tissue, and in that adipose tissue, the fat is stored in the form of triacylglycerol, and that too will form 15 percentage of the concerned person's body weight. And that 15 percentage is equal to 1 lakh kilocalorie of energy. And what is the significance of storing triacylglycerol as a source for storage fat? The importance is that in the place of triacylglycerol, if in that person's body, hydrated glycogen is stored, then that glycogen, how much is required to be equal to give this much kilocalorie of energy for that person's body? 65 kilogram. 65 kilogram of glycogen is required to give this much energy for that person. And in that place, for giving this much energy for a normal weight person, it needs only 11 kilogram of triacylglycerol. So look the difference. And in the place of this 65 kg, here 11 kg only required. And one more thing, if that energy or that source of fat, if it is stored in the form of triacylglycerol, it is water repellent, as well as it requires only a minimum space, because that quantity is very less, and that H2 can give this much amount of energy. So that's what important significance of storing fat in the form of triacylglycerol over storing glycogen. Among the reactions of triacylglycerol, first one that we are going to see is hydrolysis. Hydrolysis of triacylglycerol. As this triacylglycerol get acted upon by lipases, we know that the structure of triacylglycerol is with one glycerol group and three fatty acid. These fatty acid chains are esterified to the OH groups of this glycerol. So this is the structure. So what is happening in hydrolysis is that lipases act on this triacylglycerol and first it cleave and free one fatty acid. And as a result, what resulted? Diacylglycerol. Diacylglycerol means two of the OH group get esterified to two fatty acid chain. And it is again acted upon by lipases and the second fatty acid chain also released. And what will result? Monoacyl glycerol will form. Monoacyl glycerol means only one of the OH group is esterified to a free fatty acid. And as the lipases again acted on this monoacyl glycerol, then what freed? The remaining one fatty acid chain also freed and result glycerol plus 3 fatty acids. So that is the hydrolysis reaction of triacylglycerol. Next reaction is saponification. Saponification, soap formation. So what is that reaction? When triacylglycerol, it undergoes hydrolysis because of the presence by adding some alkali, for example, potassium hydroxide. What will result? It undergoes saponification and resulted glycerol and soap. So, triacylglycerol under the influence of some alkali, it undergoes hydrolysis and results glycerol and soap. So, that reaction is saponification. Then what is saponification number? Saponification number means it is the milligram of potassium hydroxide. We know that it is an alkali. Milligram of potassium hydroxide required to saponify 1 gram of fat. So that number, that value is saponification number. And this saponification number has a relationship with the molecular weight of the fat. What is the relationship or what is the nature of that relationship? An inverse proportional relationship exists between saponification value and molecular weight. As the molecular weight increases, the saponification value decreases. Okay. Next reaction is rancidity. Rancidity means it is the appearance of some unpleasant smell and taste for the fats that we can feel while we are eating some nuts after kept it open without properly closing. So there also the same thing is happening, rancidity. Two types of rancidity are there, hydrolytic rancidity and oxidative rancidity. And so let's see what is hydrolytic rancidity first. Hydrolytic rancidity. Hydrolytic rancidity means it is the partial hydrolysis of triacylglycerol. How? Partial hydrolysis happens because of the action of some traces of hydrolytic enzymes that present naturally in the fats and oils. So, that is hydrolytic rancidity. It is a partial hydrolysis of triacylglycerol. How? Because of the action of hydrolytic enzyme that present in naturally occurring fats and oils. In naturally occurring fats and oils, Hydrolytic rancidity. What is hydrolytic rancidity? Hydrolytic rancidity means it happens because of the partial hydrolysis of triacylglycerol. How that partial hydrolysis happens? Due to the traces of hydrolytic enzymes present in naturally occurring fats and oils. So that is hydrolytic rancidity. That unpleasant odor or taste develops because of partial hydrolysis due to the action of hydrolytic enzymes present in naturally occurring fats and oils. Then what is oxidative rancidity? Oxidative rancidity, as the name indicates, it happens because of the partial oxidation of unsaturated fatty acid that present in the lipids. And how that partial oxidation occurs because of the interaction with the atmospheric oxygen and resulted in the formation of epoxides and peroxides. Epoxides means what? It is cyclic ether. It is cyclic ether with a 3-atom ring. That's only for your better understanding what is epoxide. Peroxides means they are certain chemical compounds in which two oxygen atoms will be there. They are linked together by a single covalent bond. So that are peroxides. So anyhow, oxidative rancidity means it is a partial oxidation of unsaturated fatty acid by the atmospheric oxygen and resulted in the formation of epoxides and peroxides. And this type of reaction takes place spontaneously. That's why this oxidative rancidity is otherwise called auto-oxidation. Auto-oxidation. So, with that, we are going to finish today's class and section. Thank you. I'm an icon, man. I'm a girl about a 10. I should fuck her in the Benz.